In the domain of science and enormous investigations into the idea of presence, the subject of what existed before the Big Bang has ignited discussions and entranced personalities for ages. This significant inquiry not only tests our capacity to unwind the universe, but also challenges the ultimate limits of human knowledge. Imagine standing at the edge of existence, looking into the tremendous unknown and contemplating what lay there before our universe was conceived. The event of the Big Bang marked the beginning of history, space, and all that we know. Anyway, there was a moment prior to everything starting. Might there have been a state of nothingness, a silence before the fiery gathering initiated? If this is the case, what was it? Or maybe more intriguingly, was there something even more disruptive that existed before time itself? As we dig further into this mystery, science takes us on a journey past the universe's beginning stage into ideas that challenge our imagination. Physicist Brian Cox, known for his investigations on the miracles of the universe, suggests that something unprecedented could have existed before the Big Bang. He invites us to reconsider how we might interpret reality and presence. In this investigation, we will take apart the science, hypotheses, and shocking insider secrets that could make sense of what existed before everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even the multiverse. The discoveries we uncover may dumbfound you, yet they could also open new ways to understanding our place in the universe. Plan to dive into a world beyond imagination, where science blends with the mysterious, and the obscure creates long, shaded areas that leave scientists confused and, at times, disrupted. Let us investigate what existed before the Big Bang and why these speculations challenge all that we assumed we knew. To appreciate what could have existed before the Big Bang, we first need to understand what the Big Bang really was. The Big Bang, as described by physicists, was the event where the universe became extraordinarily hot and dense, expanding rapidly to kick off the development of all matter, energy, and fundamental forces. When we look into the night sky, we see evidence of this hot beginning, with galaxies fanning out from a singular point. Yet what made this happen? Was there a time before this dense, hot start? According to the theory of cosmic inflation, there was indeed a preceding, and it was far from empty or still. Cosmic inflation suggests that, prior to the Big Bang, the universe was in a state that was cold, vacant, and free, similar to a perfect vacuum. Anyway, this vacuum wasn't truly empty. It contained a massive amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially set up everything that would follow in a mere fraction of a second. Space expanded at amazing paces until the expansion slowed, and the energy changed into matter, particles, and the forces we know in the Big Bang. But what was the nature of this energy? Why did it arise seemingly from nowhere, driving the universe? And why did it stop? Researchers believe this inflationary process created patches of the universe, each experiencing its own Big Bang. Imagine a surface inflating continuously, with little bubbles forming. Each bubble represents a universe, including our own. This idea, called the inflationary multiverse, suggests that there may be countless Big Bangs and an infinite number of universes. Our own is just one of many. This immense, mind-bending reality challenges how we interpret the universe and leaves us wondering what else is out there. The possibility of nothingness before the Big Bang is speculative, at best, in light of our current understanding. Regardless of whether we eliminate all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces we still have yet to fully comprehend. Even in its emptiest state, the universe still contains something. Even if we imagine stripping away these forces, leaving a dead void, the universe would still produce new forms of energy. This reality confounds scientists, as it suggests that true nothingness might be impossible within our current understanding of space. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with, in a physical sense, nothing in it. No particles, no radiation, no energy. And still, after all that, quantum fields and fundamental constants would still exist, suggesting that this nothingness has properties. For example, there's a concept called zero-point energy, which refers to the lowest energy state of quantum fields. In this state, particles can still appear and disappear, creating a faint echo of motion, even in what should be empty space. This challenges our notion of a true void and implies that even before the Big Bang, something existed. Scientists are still wrestling with this. Perhaps one of the most captivating hypotheses in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's conceivable that it could continue indefinitely. Brian Cox describes a vast inflationary multiverse, where universes are constantly created and evolve. Imagine each Big Bang as a spark lighting another universe, while inflation happens in other regions, creating countless other universes. This process could theoretically continue forever. This idea of epic universes giving birth to others leads to an intriguing notion of a fractal universe, where each new universe might create its own Big Bang. Every universe exists as an independent space, unaffected by the others. For scientists, this hypothesis is both thrilling and unsettling. It suggests an endless multiverse with no clear beginning or end. Imagine our universe as just one piece in a vast, endless tapestry, forever creating and forever evolving. What if this is the true nature of reality? There is no before or after, but perhaps an eternal pattern of universes forming. How we interpret nothingness shifts when we consider quantum field theory. According to this theory, the universe is not a collection of matter floating in space. Rather, it's a complex interaction of energy processes that fill the universe, interacting to create all that we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and vanish in these fields instantly, gaining energy before returning it. This characteristic leads to virtual particles, phenomena that momentarily exist and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would it truly be empty? Would such a universe, deprived of all detectable phenomena, be completely void? Quantum field theory suggests otherwise. Even without matter, radiation, or energy, the underlying quantum fields would still make temporary fluctuations in what should be nothingness. These fluctuations could create virtual particles, fleeting bursts of energy, and subtle disturbances, ensuring that even the emptiest universe holds some form of activity. This discovery is both astonishing and perplexing. It suggests that true nothingness, a state of absolute void, may be unreachable, as even the most stripped-down version of reality is governed by the laws of physics. The challenge of defining nothingness. When we think about nothingness, we often imagine a complete absence of existence. However, in modern physics, nothing is surprisingly complex. Space itself is not an empty container. It has structure, properties, and energy. For example, quantum mechanics demonstrates how particles and energy can spontaneously arise and disappear in what we perceive as a vacuum. Even if we imagine a universe without space-time or quantum fields, we're faced with another question. What made existence arise from this nothingness? Was there an external force or rule, or does our understanding of causality break down when we step beyond the boundaries of our universe? Timeless cycles and cosmic resurrection. One fascinating idea proposed by some physicists is the concept of cyclic universes. This theory suggests that the universe undergoes vast cycles of birth, death, and rebirth. Rather than a single Big Bang, there could be an endless sequence of Big Bangs and Big Crunches, with the universe collapsing and then detonating again in an eternal loop. In this scenario, what we think of as before the Big Bang would simply be the remnants of a past universe. Evidence for such a cycle is speculative, but it could explain why certain fundamental constants, like the density of matter or the nature of dark energy, are so finely tuned for our universe to exist. The multiverse theory. Another possibility is the multiverse theory, which suggests that our universe is just one of many. In this view, the Big Bang was not the beginning of everything, but rather simply the birth of our universe within a much larger infinite system. Other universes, governed by different physical laws, may exist, aligned with our own, each with its own origin and unique history. This idea is supported by inflationary theory, which describes how different regions of space could undergo their own Big Bangs, creating bubbles of universes. Our universe is one such bubble, floating in an incomprehensibly vast multiverse. If the multiverse is real, then the question of what existed before the Big Bang shifts to, what is the nature of the multiverse itself? Could it be timeless? If so, it could explain why there appears to be no definitive starting point. Philosophical and religious implications. Theories about what existed before the Big Bang inevitably intersect with philosophical and religious questions. For centuries, thinkers have debated whether the universe had a beginning or whether it has existed eternally. These discussions often touch on the nature of existence itself, the concept of a creator or first cause, and the implications for human understanding of life, purpose, and the cosmos. Philosophically, the idea of an eternal universe or one that cycles through birth and death challenges the idea of a definitive start and end to reality. If the universe is part of an endless series of events, does it suggest an inherent meaninglessness, or does it point to an infinite process that transcends human understanding? Religiously, many belief systems describe creation as a divine act, often placing a significant emphasis on the beginning of time as the moment when God or gods created the universe. The idea of a pre-Big Bang state, or of an eternal multiverse, might seem to contradict these religious narratives. However, some theologians and philosophers have found ways to reconcile these theories with spiritual ideas, proposing that science and faith may not be mutually exclusive but instead reflect different ways of understanding the ultimate reality. In the end, the question of what existed before the Big Bang, or whether there was anything before it, remains one of the most profound and mysterious challenges in both science and philosophy. As our knowledge of the universe continues to grow, we may uncover more answers, or we may find that the true nature of existence is forever beyond our reach, a concept too vast for human comprehension. Whether we arrive at definitive conclusions or not, the search for understanding will undoubtedly continue to inspire curiosity, wonder, and awe, prompting us to question the very nature of existence itself and our place within it. As we continue to explore the mysteries of the universe, we are confronted with the limitations of our understanding and the vastness of the unknown. The theories that attempt to explain what existed before the Big Bang, or whether there was even a before, challenge the very foundations of our concepts of time, space, and existence. These ideas force us to rethink the nature of reality itself, asking whether time itself has a beginning or if it, too, is part of an infinite cycle. One of the most intriguing aspects of this ongoing exploration is the intersection between science, philosophy, and spirituality. While science seeks to uncover the mechanisms behind the creation of the universe and the forces that govern it, philosophy wrestles with the deeper questions of purpose and meaning. Spiritual traditions, on the other hand, offer perspectives that explore the nature of existence and our place in a broader, perhaps divine, context. The search for answers to these questions doesn't just involve